Let's do this, everybody. Woo! Happy ng-conf. We are so excited to be here today. My name is Nicole, and this is Zack, and we are going to talk to you about reactive code with RxJS and Angular animations, and how you can bring these two things together in your applications to make magic.
Like best friends.
Oh, yeah. We have all the code that we're going to show today in a repository on GitHub, so you can check it out. And it's also deployed on the URL that you see on the screen here. So go back and visit it later to get some great code samples. Like I said, my name is Nicole. I am a senior engineer at Narwhal, and I'm also the UX lead on our NX Cloud product. And I have been really interested in user experience and interactivity for most of my career.
Cool. And I'm Zack DeRose. I'm also a senior engineer at Narwhal, working on NX at the moment. And a lot of my focus is on state management and reactive code. Which leads us right into our first topic, which is a sort of a philosophical take on RxJS. So what we're trying to get out of RxJS, in my opinion, is simplicity. This simplicity comes from flattening the potential sources of complexity in our code. Without RxJS, the imperative options we have available to us, I think, unavoidably lead to complexity. I trust many of us have felt this firsthand, stepping through or mapping out code like a person intent on exposing a conspiracy. Only we are the ones willfully creating our own conspiracy for our future selves to solve later. Angular can be particularly tricky in this way, as change detection can lead to unexpected states or order of events hidden inside of our imperative code. RxJS instead allows us to define a property in terms of how it will change, confined to one spot in our code. One entire definition for the entire lifecycle of that property. In addition, RxJS provides us with discrete and observable events as to how these properties change. These help us avoid the pitfalls that come with handing over the reins of our application to Angular change detection, and it can also be particularly helpful for crafting animated experiences in our applications. So to see how we can practically use RxJS, we have a click counter example. Cool. So here is an example of our code. Let me refresh real quick. So we can see we have a button here, and our application is telling us how many times we've clicked the button in total, as well as how many times in the last second, 5 seconds, and 15 seconds we've clicked it. So as I click it, you can see the counters are dynamically adjusting themselves, and our graph is also automatically adjusting itself as we go. And so if you can imagine the code for this, if you take an imperative approach, it could be very complicated, but we're going to break this down into reactive implementation, and we're going to see how simple it can be. So we're going to start with getting a observable from our mouse clicks. So an observable at the end of the day is very much like a timeline. It has a start, it has an end, and it has some events that occur along the way. Right here we can see this is a piece of code to create an observable of mouse events from a button's click. So we can see we're taking in an element ref, this returned from the view element decorator, or view child decorator rather, and we are taking that target and taking its native element and the click event and passing it into the from event helper from RxJS. And that gives us this nice observable or timeline of the clicks that have occurred. But we don't want necessarily just the clicks. We actually want a observable of the number for how many times it was clicked. Keep in mind the total click counter that we saw in our example. So how do we get from here to here? Well, going from one timeline to another, that's actually called an operator in RxJS. It takes one timeline or one observable and creates a new one. So to step through how we can get from what we have to what we want, we can start by using the scan operator. we can see in this animation, we are taking our click events from before and we're scanning them to take the previous emitted event and adding 1 to it, starting with 0. So that gives us this nice timeline where we see most of the data we want, but we're still missing a 0 at the beginning, if you recall. So to do this, to add that 0, we're going to pipe on another operator at the end, start with 0. And that does the same exact thing as before, because we're just taking the previous observable and essentially just appending a 0 onto it. And we have arrived at what we want. And as you can see, in terms of our mental model, we have our starting or incoming observable, and we return a new observable. And we can export this as a function and just use this inside of any old observable pipe. So that's very cool. But to get to our more intense example, the windowed count, we'd want to take we'd want to take the same principles, we just want to take a little different way around it. So we're going to go through the same steps here to trace this through. This is what we have, again, our clicks, and this is what we want, a windowed count where we see the count going up and down based on the duration of our window. So to start, we'll look at we'll start with the timer. This is exposed by RxJS, and this will just, based on the duration provided, will create like a counter for us, just counting from 0 on up with a window based on the duration provided. But we only want the first 2 of these, and so we're going to add the take2 operator onto that. Then we actually don't want a 0 and a 1. What we want is a +1 or a -1 based on our window size. So we can see adding this map operator here will do that for us. And so this will actually give us, we can condense this down into this simple little piece of code that will create a window observable for us, an observable of 1 or -1 that always just emits 2 things based on the window size. Once we have that piece, we can use merge map to kind of take our initial observable, and we're going to kind of spawn different observables based on that previous observable using our window function that we just created. And then what merge map is going to do is actually flatten all these down onto one observable we see at the bottom here. So this is most of the way to what we want. Actually, at this point, it's very similar to count, but we can take what we have here, and we are going to scan it to just add up all of the different 1s and -1s as they come in. So you can see go up to 1 and back down to 0, and then climb as high as 2, and then we get our -1s again, so we go back down to 0. And we're still missing our 0 at the beginning, so we'll just add a little start with 0 at the front there, and we're pretty much there. We've arrived at the operator we wanted. We can call it windowed count. You can see here's the code for all of that. So yeah, that is how we can use RxJS to drastically, in my opinion, simplify the code rewrite and make things more reusable and more fun to work with. So yeah, Nicole, going back to you for animations.
Okay, so let's talk a little bit more about the animation side of things. So before we talk about Angular animations, I wanted to mention a little bit about why we would want to add animations to our application in general. A lot of people, I think, probably see animations as unnecessary polish. And while they certainly aren't, in most cases, as important as core functionality, they are a way to get improved UX in your application or your website. They help your user understand transitions between states and whether an action that they took was successful. If they delete an item and it transitions off of the screen, that helps your user know that something was an action was taken cleanly. They also allow us to draw attention to key parts of our application. So we don't want to add animations to every part, every element on the screen, just the ones that are really important and we want to draw attention to. So where does Angular animations shine when it comes to like all the different options that are available for creating animations? Angular animations is not like libraries like GreenSock or D3, where you're able to create very complex animation sequences. Instead, with Angular animations, usually what we're doing is defining transitions between states. And this is something that's actually really easy and elegant to do with CSS animations and transitions. But there are a couple places where Angular animations really outshine CSS animations. So let's take a look at some of those. One of them is when you're staggering items. So in this case, we have a series of items that are coming onto the screen, and we want to add a little bit of a delay in between each one as they enter and leave. With CSS, this would be quite a bit of code. You would be generating a lot of classes. But here, we can do it really easily with Angular animations. And I don't have an example that I'm going to show today, but there is one in the repository for you to check out. So be sure to go to the GitHub repository if you want to see how this is done. Another example of some place where Angular animations shines is when you have elements that are entering and leaving the screen. So this might seem like a pretty basic example. And actually, like having something enter onto the screen with CSS is very easy. But if you're trying to get something to animate as it's leaving as well, that is more difficult to do. But Angular animations does make it easy, and it allows you to also specify callbacks when the animation is complete, which is pretty cool. So if we wanted to see how to actually do that animation that we just saw, let's walk through some code. So the way that we specify animations in our Angular code is to pass some metadata into our component decorator like this, into the animations array that you see here, or sorry, the animations property that you see here. We're passing an array of triggers, and that is going to be a container for all the other animation function calls that you're going to pass in here. And it takes the name of your animation and an array of states or transitions. A transition defines the changes that occur between one state and another over a period of time. And it takes an expression that you can see there, void, and then the arrow to a star. And that says that whenever you're going from nothing to any state, I want you to play this animation. And then we're going to pass to the transition a series of style and animate steps that are going to tell the transition what is going to actually change. An alias for the void to star is enter, and there's a corresponding one for leave. These are aliases that are provided by Angular to just make it a little bit more readable. And then we have an animate function here that defines the length, delay, and easing function of a transition. And then you can pass a style function that lets you pass in a number of properties that you want to animate as well. Now that we have our animation defined, we can add it to our element. It could be a component or any element on the page. And we pass in, or we have an @ symbol and then the name of our property that we want to, the name of our animation. My recommendation usually for an application is to use 2 to 3 animation styles. This helps you keep your animations really cohesive and allows them to complement each other, and it just makes things feel better. And so for that purpose, I recommend using reusable animations. So let's quickly take a look at how you would define the animation that we just saw in a reusable animation. So this is us defining the same thing, but in a constant. This would be in a file that's separate, maybe in another library. And NX makes it really easy to have a library of animations, just import them into any component that you have. In this case, we can also pass in some parameters to slightly adjust certain values when we want to use them. So we import in our animations into our component, And then in our animation metadata, we can use the same trigger function and then use the use animation function here to just pass in the animation that we've defined. And you can see that the code here is a lot more terse. Cool. So Zach and I wanted to show you an example of what you can do when you bring together reactive code and animations into an example like a carousel. So we have a custom image carousel here. It allows you to move to different slides or like sets of images by clicking on the buttons. And we have different styling and different animations for each image. Yeah, so let's jump into how this works. In the template of where we're actually like defining the carousel, you can see that we have both the carousel component and a carousel item component, which defines each slide. And then into each item, we're passing 3 images. And we have some like arbitrary classes that are just meant to show different styling. And we're passing the state into each item. And let's check out in the carousel item how the animations are defined. So in the item, we are defining 3 animations for each image. And we are passing in we're importing in a series of animations from this shared library. And then when we use the animations, we are also using parameters here to get the animations coming in from different sides. And we're also adding a delay here. So that's how we're kind of getting each individual animation. And then in our template, we are selecting the data image of 1, 2, 3, and then we apply the animation to each. So over to Zach to talk about how that is actually, the functionality works.
Cool. When we think about the example that Nicole just showed for us, the thing I want to focus on first is when she was clicking the different buttons to advance us from state to state. And so we can imagine, whereas our click counter had one timeline for the specific buttons click events, this one actually will have 3 different ones, one for Patrick's, SpongeBob, and Gary. So as you can see here, this might be, as Nicole's clicking, she clicks SpongeBob, then Patrick, then SpongeBob, then Gary, then Patrick again. And we'd want a new timeline based on that kind of advances, a single timeline that shows us which state we're in. So to get to this, we'll use merge. And merge will take our 3 observables, pass them into this utility function exposed by RxJS, and it will give us our nice little observable at the end. As you can see, as we're clicking here, the resulting observable is a observable of the state changes as we go. So this is great. This gets us, if all the carousel was doing was just going from state to state based off of the clicks the user performs, this is enough to get us there. But since we also want to advance our carousel automatically based on a given duration, we'll want to create this auto advance operator to take us from what we have, which is, this would be the result of that previous merge where Nicole clicks on SpongeBob initially, and then somewhere down the line we click on Patrick. So auto advance would take in a duration and would kind of result in this observable at the end where we wait that duration each time stepping from state to state until we see Nicole click on Patrick, in which case Patrick kind of interrupts and starts a new observable that starts a new chain of the sequence here. So just to break down how that's all going to look, let's start by just taking a single SpongeBob to start with. So we want to take this SpongeBob and we want to take him and create 2 timelines from him and merge them together. So the first timeline is going to be a timeline that starts and ends immediately, only emitting SpongeBob. And that will be our initial timeline. our second timeline will be using the interval of the duration given to us at the top level. We're just going to start and wait until that interval elapses, and we'll step from state to state, going on forever, using the scan operator like we saw in our previous example. And what this will result in, because we use merge again, is just going to flatten these all down. So our resulting observable looks kind of like this, which is exactly what we want. Nicole clicks SpongeBob. That's going to emit a SpongeBob immediately, and then begin progressing through the sequence of expected states. However, if we want to take into account other clicks to the carousel, so sort of like an interruption to our auto-advancing, we'll want to use the switch map operator to do this. And we can see we'll start with the logic we were just looking at. That's what's inside of the switch map here. So we'll be starting with SpongeBob, advancing from state to state. But when we observe a click event from Nicole right there, we can see Patrick comes in, interrupts, and we switch from the timeline that was beginning there with SpongeBob to a new timeline we created using the same code, but starting with Patrick this time. And so by doing this, we essentially get to our desired behavior. This is the auto-advance operator we were talking about at the beginning. So as a result, we have this function, our auto-advance operator, that we can export and use here in our carousel. We could also use it for any other instance where we'd like to auto-advance our observable from one state to another. And so that is the majority of the reactive code that we've done in this example. Check out the repo if you're interested. There's also some interesting stuff we do there where we encapsulate this all into a closure and expose only a state change callback that we map our clicks to, and then just expose a single observable, so the consumer of our closure doesn't even know any of those operations are happening. They just get a nice little observable out of an object, and we throw that in our template, and we're good. So yeah, that is how you make an awesome best friend reactive animated carousel. Yeah.
Woo!
Woo! We did it, Nicole.
Sweet.
Best
oh
friends.
Yeah.